In the spring of 1943, assembly lines in Germany began producing vehicles that would become one of the Wehrmacht's most mass-produced series of heavy, self-propelled guns. This weapon system was based on Czech-made light tanks, which by that time were considered obsolete and couldn't compete on equal terms with modern armor. The engineering solution was to convert the existing chassis into artillery units capable of striking fortifications from a distance of about 3 miles. That is how the Grille model, Modification M, came to be, a vehicle used right up until the end of the war. The project was driven by the situation with the 38T light tanks, which were completely obsolete by early 1943. Their armor and firepower were insufficient to effectively counter new enemy vehicles. Using these vehicles in their original form posed unjustifiably high risks to the crews. Nevertheless, the chassis was still technically sound. The engines and running gear had plenty of life left in them. Scrapping such a large amount of hardware was considered a waste of resources while fighting a war on multiple fronts. Engineers already had experience mounting heavy guns onto various tracked platforms. They had previously created self-propelled variants with a 150mm gun, but those had a number of technical flaws. A batch of 90 units of the previous Grille modification had already been delivered to the troops, but operational analysis showed a need for improvements. The main problem was the forward placement of the fighting compartment, which made the vehicle unstable. Shifting the center of gravity forward impaired handling, while the high profile of the superstructure made it too visible on the battlefield. The solution was a complete redesign of the layout. The engine compartment was moved from the rear to the center of the hull, the transmission was placed in the front, and the fighting compartment was shifted to the back. This reconfiguration of the chassis eliminated the main flaws. The center of gravity moved to the geometric center of the vehicle, weight distribution was optimized, and the overall height was reduced by over a foot. The modernization of the hull was extensive. The front was now formed from 2 massive plates, 20mm thick. The lower armor plate was vertical, while the upper one was sloped back to improve protection. The right side of the upper plate featured a housing for the driver with 15mm thick walls and observation devices. Side armor was 15mm, and the rear was protected by 10mm plates. A distinct feature of the design was the fighting compartment superstructure, located over the rear of the hull. It was designed to be as compact as possible to reduce the vehicle's silhouette. The front of the superstructure consisted of 2 plates, sloped inward and angled relative to the vehicle's axis. The sides and rear were also sloped. The superstructure was built from 10mm armor, providing protection against shrapnel and bullets. A movable gun mantlet was placed between the front plates, covering the opening as the barrel was raised or lowered. The 145 horsepower Praga engine was moved to the center of the hull, which required a complete redesign of the cooling system. The old grills on the hull roof were removed, and the air intakes and exhaust pipes were routed to the fenders on the sides of the vehicle. A slight increase in the power plant's output helped compensate for the increased weight of the design, keeping mobility at the same level. The self-propelled gun's main armament was the same weapon used on the previous version, the heavy 150mm infantry gun, Index 33. This artillery system offered significant firepower for infantry units. The 11 caliber long barrel was rifled to impart spin to the projectile, which helped improve firing accuracy. A horizontal sliding breech block ensured a decent rate of fire, while hydropneumatic recoil mechanisms absorbed the heavy kick of the gun. The ammunition used separate loading and included several round types to handle different missions. High-explosive fragmentation shells were designed to hit personnel and light cover. Concrete-piercing rounds were for destroying pillboxes and bunkers and smoke shells were used to screen troop movements. The muzzle velocity was 790 feet per second, a standard figure for a gun of this caliber. Maximum range reached 2.9 miles, allowing it to strike targets deep in the tactical zone without exposing the vehicle on the front line. A skilled crew could maintain a rate of fire of up to 3 rounds per minute, which was considered a good figure. Given the significant weight of the shells, loading required serious physical effort from the crew, especially during intense firefights. An ammunition load of 18 rounds was stowed inside the fighting compartment, enough for about 6 minutes of continuous fire. Resupplying meant withdrawing to the rear or bringing shells directly to the position. A limited horizontal traverse of 10 degrees, 5 to each side, forced the crew to pivot the entire vehicle to hit targets outside that arc. Vertical elevation ranging from 0 to 73 degrees allowed for high-angle fire against targets hidden behind obstacles. The design of the movable mantlet limited these angles, a trade-off accepted by the developers to balance protection and functionality. For secondary armament, a Model 34 machine gun was stowed inside the fighting compartment without a fixed mount. To repel infantry attacks, the crew had to fire over the side of the superstructure, which exposed them to high risk. However, tactical doctrine dictated that the self-propelled gun should operate deep in the formation, covered by Allied units. The crew consisted of 4 men with clearly defined duties. The driver was stationed in a separate compartment at the front of the hull, driving the vehicle via vision blocks and handling maneuvers. The commander sat in the fighting compartment to the left of the gun, directing the crew, selecting targets, and giving orders to fire. To the right of the gun and behind the commander were 2 loaders, one of whom doubled as a radio operator using the Model 16 radio. This division of labor helped maintain the rate of fire in high-stress situations. The vehicle's driving performance was powered by a stronger engine. On paved roads, the self-propelled gun reached speeds of up to 22 miles per hour, allowing it to change positions quickly. It had a range of 110 to 120 miles, enough to operate for several days without refueling. Cross-country speed was lower, but off-road performance remained acceptable, thanks to wide tracks and moderate ground pressure. Once design work was complete, an experimental model was built. The prototype went through a cycle of comprehensive field trials to test components and assemblies, including ballistic tests, to evaluate armor resistance. The trials were a success, and a production order followed immediately. Assembly of the first units began in April 1943, right as production of the previous version shut down. The factory was tasked with building 200 units on the updated chassis under a strict timeline. The situation on the front lines demanded that artillery units replace their losses and get equipped with new hardware. Production lines ran at full capacity, working in multiple shifts. Finished vehicles rolled out of the workshops regularly and were sent straight to the active army. The manufacturing process didn't face any major delays, as the assembly methods had been worked out on earlier models, and the production of most components was already mastered. The completed self-propelled guns were quickly handed over to the customer and distributed among units. They were shipped by rail to the areas where they were needed most. Some vehicles went to replenish units already operating heavy infantry guns on self-propelled chassis, while others went to equip newly formed formations. By October 1943, Command realized that the initial production volume wasn't enough to meet current needs. In the field, the vehicles proved highly effective. There was a demand for these machines, and artillerymen gave high marks to the firepower and ergonomics of the new layout. A second order was approved for a large batch of the M modification. The plan was to equip the troops with this weapon as fully as possible. However, the general strategic situation and economic problems affected these plans. Industry faced shortages of raw materials and manpower, as well as the consequences of airstrikes on factories and transportation hubs. The shortage of base chassis produced by subcontractors became critical. Supplies were unstable, and existing resources were often redirected to other projects. To keep producing the artillery systems, engineers had to find technical compromises. Production of this model continued until September 1944, when it finally ceased because the capacity for further assembly was exhausted. The main reason production stopped was an acute shortage of 38T light tank chassis. As manufacturing plants were repurposed, the supply of components dropped significantly, and the available chassis was split between several parallel projects. In the end, the final batch of 10 units was assembled on the non-standard chassis of Flak Panzer 38T anti-aircraft systems, which required additional design changes. Between October 1943 and September 1944, 82 self-propelled guns were produced. Counting the first batch of 200 machines, the total number of these units delivered for service was 282, including those on non-standard chassis. This production run was the largest among all German projects mounting 150mm guns on a self-propelled base, surpassing the numbers of previous models. At the same time combat vehicles were being built, support vehicles were also under development. By early 1944, a design was ready for an ammunition carrier, intended to supply both modifications of the self-propelled guns directly on the firing positions. The transporter shared the same design as the artillery system, using the identical chassis, engine, and running gear. Instead of a superstructure with a gun, a cargo platform with sides and mounts was installed on the hull, designed to carry up to 40 rounds of 150mm ammunition, with shell casings and charges. One of these carriers could supply a full combat load for 2 self-propelled guns, or allow a single machine to keep firing for a long time without needing to change position. Having this specialized equipment helped boost the efficiency of artillery units and maintain their rate of fire. Assembly of the carriers was carried out from January to May 1944. In total, about 120 units were produced, which matched the needs of the self-propelled gun fleet. The vehicles were sent to the same units where the artillery pieces were operating. The crew consisted of 2 or 3 men who operated the vehicle and handled the transfer of ammunition under combat conditions. Introducing this new modification didn't lead to changes in the organizational structure of units equipped with heavy self-propelled infantry guns. No new types of formations were created. The incoming equipment was used to reinforce existing companies that were already fielding various vehicle types and modifications. This approach ensured the troops were saturated with equipment without needing to overhaul the existing organization. The unit structure remained the same, allowing for the appearance of additional platoons as hardware arrived. A heavy infantry gun company usually included several platoons of 2 or 3 vehicles, a command section, as well as support and repair groups. Starting in early 1944, heavy infantry gun companies began to include ammunition carriers that shared the same chassis as the self-propelled guns, which optimized logistics and increased the autonomy of the artillery units. According to archival records, the Grille M self-propelled guns entered service with several dozen separate companies across more than 30 Wehrmacht divisions. The significant number of recipients and the wide geographic distribution of the equipment meant it saw action on practically every European sector of the front. The equipment was used wherever infantry and tank support, suppression of fortified positions, and rapid maneuvering of firepower were needed. Vehicles of this type were first used in combat on the Eastern Front in the summer and autumn of 1943. The self-propelled guns went straight from the production line to active units. Crews went through a crash course in training and were sent directly to the combat zone. Command distributed the new equipment to sectors seeing the most intense fighting to hold back enemy offensives or support counterattacks. The Model M proved effective at destroying field fortifications. The 150mm shells possessed high destructive power. Direct hits could demolish bunkers and trench shelters. High explosive fragmentation rounds provided a significant blast radius. When firing at infantry concentrations, they inflicted substantial damage on manpower. The blast from a large caliber shell could take out an entire group of soldiers. Its high arcing trajectory allowed it to hit targets hidden behind reverse slopes and in lowlands, places inaccessible to direct fire guns. These self-propelled guns usually operated in groups of 2 or 3, positioned deep in the battle formation, several kilometers back from the front line. This kept them out of direct contact with anti-tank weapons that could easily punch through the vehicle's light armor. Commanders chose concealed positions for deployment, using the terrain, forests, and villages for cover. After completing a fire mission, the vehicles would relocate to avoid a counterstrike. Onboard radios provided communication within the company and with higher command. Spotters relayed target coordinates, after which the crews would aim and load. Following a ranging shot and adjustments, they would fire for effect. Skilled crews could destroy a target while wasting very little ammunition. Transporters followed the combat vehicles to quickly resupply them. Reloading took place at the rear of the position, allowing them to maintain a steady rate of fire for long periods when repelling offensives or supporting attacks. In the winter of 1943 and spring of 1944, these machines continued to see action on various sectors of the Eastern Front, participating in defensive operations across Ukraine, Belarus, and the Baltics. The Grille self-propelled guns were deployed on front sectors where there was a need for heavy fire support. During operations, equipment losses were inevitable. Vehicles were destroyed by artillery fire, blown up by mines, broke down on difficult terrain, or were destroyed by their own crews when evacuation wasn't possible. After the Allied landings in Normandy on June 6, 1944, and the opening of the Second Front, German command began shifting forces to the west, which weakened the defenses in the east. Among the tank and infantry units being redeployed were artillery detachments equipped with these self-propelled guns. The equipment was loaded onto railway flat cars and transported across Germany, mostly at night, toward the French coast and the combat zones. On the Western Front, the conditions for using self-propelled artillery were different, driven by the enemy's tactics. Due to Allied air supremacy, vehicle columns moved mainly under the cover of darkness, and during the day, camouflage was used to hide from aerial observation. Enemy artillery, having the numerical advantage, laid down heavy fire, forcing the gun crews to constantly change firing positions. Despite this, the units continued to carry out their missions, supporting counterattacks and covering retreating forces. They fired on armor, fortified positions in towns, and enemy artillery batteries. The 150mm guns remained effective against most types of targets, with the exception of heavy armor. The operational intensity was high. Crews fired many rounds and were constantly maneuvering to escape retaliation. By the fall of 1944, the situation on both fronts had become critical. In the east, the front line was shifting toward the German borders. In the west, Allied troops had reached the Rhine. The self-propelled guns were used in rearguard actions, covering river crossings and holding defensive lines. A significant number of vehicles were not lost to enemy fire, but were abandoned due to mechanical breakdowns or fuel shortages. Maintenance units couldn't keep up with the workload because of a lack of spare parts and the transfer of technical personnel into infantry units. The winter campaign of 1944 to 1945 took place right on German soil, where defensive battles were fought against advancing troops from the east and the west. The Grille modification M self-propelled guns remained in service, despite general wear and tear and logistical problems. Repair crews managed to keep the machines combat-ready under difficult conditions. Statistics from February 1945 show there were 173 units of this modification still available out of the 282 produced. This figure was a testament to the vehicle's high survivability after a long period of service. The remaining machines saw action in East Prussia, in the defense of the Oder, in Silesia and Pomerania, as well as in the battles for the Ruhr. Supplies of ammunition, fuel, and spare parts became increasingly irregular, leading to a drop in the number of combat-ready units. Yet the vehicles continued to be used until resources were completely exhausted. According to some sources, in the spring of 1945, a German industrial plant was tasked with repairing a group of damaged Grille units to get them back into action. There is no reliable information on whether this work was completed or if the restored machines saw combat before the surrender. Most likely these vehicles remained in factory halls and repair depots when hostilities ended in May 1945, just like so many other pieces of weaponry. The Grille Modification M project was the designer's final attempt to mount a 150mm gun on a self-propelled chassis. With a production run of 282 units, it surpassed the volume of all previous models and confirmed the soundness of the technical decisions made. The rear-positioned fighting compartment layout proved successful, allowing for a capable combat vehicle to be built on an obsolete tank chassis. This marks the end of the operational history of this self-propelled gun, which served on various fronts from the spring of 1943 until the very end of the war.